Hello all my JavaScript friends, this is the Virtuoid, aka Mike Smith, and this is Fun with JavaScript, our racing game. So this starts the series on how the cars are created. Now I was trying to figure out, in fact I spent the whole weekend trying to figure out exactly how I was going to present this information. I can present to you the entire file as it is, and it's huge to be able to work with the car. Not only the base car class, but how to apply all the models. And I just thought that's just going to be a heck of a lot at the very beginning. So I figured what I'll do is let's just start with the basics. I'm going to start with a very simple screen, and I'm going to take it one step at a time, showing you how I was going to create the wheels, how we're going to create the joints, how we're going to connect the wheels up to the joints, how we're going to create chassis, and how we're going to get everything to roll correctly on the sloped screen, which is what you're how to get everything rolling on a sloped ground, which is kind of what you're looking at right now. This is a ground that's been sloped. And so I'm not going to show you the track or anything like that. We're just going to create the car in isolation on this sloped ground so that we can see how everything works. And we'll take it just basically one step at a time. So if you're ready, let's go ahead and start. So the first thing we're going to do is we're going to get this page up and running. It's just an HTML file, JavaScript file, and CSS file. And I'm going to go ahead and just create all of those and then very quickly go over what we're looking at. I kind of did that months ago when I first introduced this video here, but so this will be more of a recap than anything else. But let's go ahead and get started. And so what I'll do is I'll create all of the different pieces, and then I will see you back when it's ready to go. Okay, I've got a blank screen coming up because it has an error occurring, and that error is this. Normally I would have just said, basically said, I made a mistake, I would have fixed it, and then we'd continue on. But this is something I wanted to show you because I made a mistake early on in my original videos that I now have to correct. And that was with our import. I imported the wrong mo.js file. Notice I'm importing 0010 here. That's not the correct mo.js file that I need to use within a ES6 module environment. The actual real one is that one that I have to use. So I've done that. I'm now going to bring in this is my original dev thing. I'm going to just do that. I'm going to do npm install, and we'll see you when it's done there. And through the magic of television, that's done. So let's do an npm run dev to get into our development environment. And it's in our development environment. Let's bring this back up. It's actually refreshing now. And yep, there we are. Ding, 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 ding. We got it. So yeah, that was a mistake I made on my part. So now we can fix that. Everything is now rip-roaring ready to go. So let me show you what I have added here. I've added basically three different files. First of all, this is my testcar.html file. And it's extraordinarily simple. I'm running in a new style sheet I called race.pcss, and this is actually the same style sheet that I'm going to be using for the race game itself. So it's got a lot of extra stuff here that we don't use with this particular test here, but I figured, what the heck, this has got all the canvas stuff already in it, so let's just go on ahead and use the one that we use for the race game itself. And that way we don't have to cover it ever again. So there's our PCS. This is going to be our testcar.javascript file that will basically is our module that will run in JavaScript. So that's all there is to this one. So let's take a very quick look at what the JavaScript looks like, and that's in testcar.js. Yeah, by the way, first of all, I meant to say I added race.pcss in the CSS file. I added testcar.js inside the JS file, and my testcar.html inside the source directory. I said file, I meant directory. You know what I meant. Anyway, let's go to testcar.javascript. And this is an extraordinarily simple file. The whole idea here is just to get a ground up on the screen so that later on we'll be able to pop a car in there. So basically what I've done here is I've created my engine, my Babylon.js engine. I've created my scene. Here's my camera, setting up the camera itself. Here is the light. A lot of this is basic Babylon.js. I've gone over it before in an earlier video. So this is just something I'm hard coding here just to get a ground that is sloped. And basically we're enabling the physics. There's my ammo.bind.js. This is the enable physics. Here's the acceleration, gravity acceleration constant. Ta-da-ta-da. And that's my plugin, no big deal. Here's the ground. We're creating an 8x8 ground, and this is where I actually rotate it. And this is basically rotating along the z-axis so that when the object that we will be creating, eventually the car hits it, it's going to start rolling. That way we can take a look to make sure that the wheels are working correctly and all that kind of fun stuff. And then we create the physics imposter. And the physics imposter basically says, okay, this is going to apply physics, in this case ML.js, to our particular mesh. And we're applying it based upon what we call a box imposter. And it's a box imposter because this is basically, it's a flat box, if you want to put it that way. I'm giving it a mass of 0. That basically means that if it has no mass, it's not going to move anywhere. It's not going to go anywhere. Right now, I've got it falling along the y-axis or going downwards along the y-axis if the thing has some sort of mass. Since it has no mass here, I've decided I don't want any, this way it's going to stay stationary. And when something hits it, it's going to stop. And that basically is what a ground does. Ta-da-da! Give it a little bit of friction so it just won't go, it won't be going all over the place. I'm giving it just a little bit of restitution here, a little bit of bounce, It's fun to have a little bit of bounce here and there. And that's pretty much it. We got the render loop here, which does the render. This render loop runs at about 60 FPS approximately. Depends upon what other stuff you got going on in your computer. That's about as fast as it can actually run. And so when we do all of that, this is what we get. It's a ground. That's it. There is nothing else there. So let's go ahead and create the basic car. And we'll work through the car. So what we're going to do here, I'm going to create the car as if it was, or actually in the same model that I did the car class. In the actual code, I've got a car class, a base car class, which does all the physics, all the wheels, all the everything for you automatically, and you just apply the models to it. So even though we're not going to go into the extreme detail of how that model was made, we'll do that once we finish showing you all the basics here. At least I'm going to try to develop this little test or this little demonstration base so that it will look like the car class. So let me just show you how that will work. So let's go ahead and create that JavaScript file, and we'll call it CarBase. So we'll create a new JavaScript file, call it CarBase, and let me pop some code in there because in my FWJS.-race I actually have some code that I'm using. And there's the magic of television. There it is. So what does it look like? Well, basically, what we're going to be creating first are the wheels. And so what I want to show you is basically how to create a mesh that will respond to gravity and will roll. Because basically that's what a wheel does, is that it rolls. So I'm creating car base. And right now there's not a whole lot in it. We're going to have a position, we're going to have a wheel, and we're going to have a scene. And this wheel is going to be what we're going to look at first. And I'm going to be creating basically a wheel. And as we go along here, obviously there'll be 4 wheels, and there'll be bodies and chassis and all that kind of fun stuff. But for right now, we're just going to create a wheel because we're going to take this one step at a time. Here are the options I'm going to use for the wheel. It's going to have a mass of 1, a restitution of 0, and a friction of 10. Notice that's pretty much the same thing that I have with the ground. The ground has an option of mass, friction, and has different values for mass, friction, and restitution. But with the car base, I'm especially giving it a mass of 1. That basically means that, hey, it's going to respond to the gravitational constant, the gravitational acceleration that we have defined here as being along the y-axis. So that now basically means that whatever happens with this one, this wheel is going to respond to the gravity. The constructor's no big deal here. I got the scene, I got the position, I'm getting that from the arguments. Notice I'm cloning off the position, and that's extremely important because the position actually within Babylon.js, and in fact, even within the car class that we're going to be using, which is trying to obfuscate Babylon.js as much as possible, that's going to be an object. And when you pass objects, objects are passed by reference. So if I just said position here, and then this position and then I physically somehow reset this position to something else, there will be a problem in that it will also not only reset this position, but whatever position was passed into it. So by doing a position.clone here, this allows me to be able to get a fresh copy of position that is completely separate from any position that I passed in. That's basic computer science there. I don't want to mess up the input that came in. I don't want to change it. I want to just use my own stuff here. All right, so basically we have a constructor, and the way my models work is that the constructor does a whole bunch of fun things, but it doesn't actually build the model. When you select, because we just want to have it inside memory ready to go when it gets built. So when it gets built, it puts it into the scene. So we don't want to put it into the scene so we want to get ready to do something with it. So we don't build it, we don't put it in the scene within the constructor. We have our own build method. And this build method, very simple in this case, again, because we're going to start testing here. This is the wheel, and basically very simple. I'm creating a sphere, I'm giving it a diameter of 5, and I'm applying it to the scene. Setting the position, and then I'm setting the physics imposter. And that basically applies physics to this particular quote-unquote wheel. Actually, it's just a simple sphere. So once we have all of that, how do we use it? Well, let's go over to test car, and then within test car itself, it's very, very simple. In fact, I'm just going to copy, so you won't have to see me suffer. So you don't have to see me suffer typing in stuff. I'm just going to copy paste. We just have a new CarBase. Let's import that. We've got that imported, so we're going to import CarBase and give it a position and a scene, which are two of the variables that the CarBase wanted to use inside the arguments, position and scene. So, whoopoo. And then we run the build. That puts it into the scene. So we should be able to see a ball. And this ball, by default, my ground is at X of 0 and Y of 0. So I'm actually putting the ball 2 places above on the Y-axis, so we should be able to see it fall and then hit the ground. And because we're rotating the ground, we should be able to see it start the roll. Because the ground is rotated, it's got the pressure of the gravitational acceleration constant that I've defined here is going to tug on that ball and say, hey, you need to come down the x-axis, the z-axis, because that's my slope here. And the ball's going to say, sure, I'm going to start rolling down the z-axis. So we've got all that. Let's save it. Let's bring it up. Boom, there it goes. Now, you've seen all this before. This is kind of real simple stuff. If you ever worked with the 3D stuff that you've seen all the time. So what we're going to do next here is we're going to create 4 balls to represent each of the 4 wheels. And then after that, we're going to connect the wheels together using a joint. So let's get to the 4 wheels next. Okay, everybody, let's now go ahead and let's do the 4 wheels. Now, one thing I want to show you here is that I did record this on 2 separate days, and I realized in between those days that I kind of fully didn't flesh out the code exactly the way it is in my CarBase that we'll be using a little bit later on when we get everything put together. So I did make a couple of changes from what we had last time. I've got a set of defaults up here for the wheel. There's no big deal there. And then within the constructor, I've got a private variable which I do set the defaults in which I set it to a scale. And this is very important because obviously I want to be able to scale the car based upon how the track is being built. That was one of the ways that I was able to get this thing working the way I wanted it to work, is I needed to have the scaling of the cars done in, basically to match the track. And by default, I just take whatever I have there. And then the only difference that you would have that what I had before is I've got the wheel options has now been moved down to here. And here's my defaults for the diameter, and the wheel options are onto the onto the physics inspector themselves. And so when we do it, this is what we get. So obviously it's a lot bigger now because of the scaling. So what I'm going to do is I'm going to go into testcar.javascript, the testcar.javascript here, and I'm going to put a scaling factor. We got a position factor there. Let's put a scale of, we'll put it 0.5, just half the size of what it was. Let's see if that does anything. Yeah, that's going to be a little bit easier to kind of see and kind of take a look at there. If I remember correctly, off the top of my head now I can't remember, I think the scaling factor was 0.35 is what I ended up using, but it doesn't really matter. Let's go ahead and do it with the CarBase. Alrighty, so let's create the 4 wheels. What are the things we're going to need for the 4 wheels? Well, one of the big things here is that if you imagine the car itself, you can imagine the car as one big huge rectangle, for lack of a better term. Basically what we want to do is we want to try to figure out the center point of the rectangle, and then figure out the position of the 4 wheels based upon the center point of that rectangle. And so what we're going to need to do is I'm going to create an array, and that array is going to have my defaults for the wheel parameters. And these wheel parameters is basically going to be able to tell us, hey, these particular defaults are going to be based upon where the center of the chassis is. So let's throw some of that code in there. Okay, and through the magic of television, we've got some additional code inside here. First of all, I've defined a chassis. Basically, the chassis is, you can think of it as representing the box itself. And this is basically saying that the height of the chassis is going to be 0.5 of whatever number of my scale. The depth is going to be 3, and the depth in this particular case, in our relationship, excuse me, in our particular game here, the depth is going to be from one side of the car to the other. You know, like from the left front to the right front. That's going to be the depth, and the width is 8, and that's actually from the measurement from the front to the back. So this is the measurement of our particular chassis, and later on in another video we'll show you. We'll add on to our wheels here and create the chassis. I determine a height, depth, and what I call a base adjust. And basically this is from playing around with it. This allows me to be able to basically say, hey, I need to be able to position the particular wheels at the 4 different corners based upon the size of the chassis that I've developed. And that's within what I'm calling the wheel parameters. Basically, I'm giving it names: right front, right rear, left front, left rear. And this is the pivot point. And that pivot point is going to be very important when we do the joints, which is going to be actually part of our next video. And these joints are basically saying that, hey, this particular wheel, or the middle point of this particular wheel, the pivot point specifically, is going to be located at a X position, at an X place of a half depth plus a base adjust, which basically means, you know, we've got the wheel itself is going to be halfway from the middle part of the car, and then the base adjust basically is going to subtract it a little bit from the front, because we don't want it directly into the front itself. We're going to basically try to bring it just a tad in from the very front of the car. The Y position is going to be the half depth itself, and again this is the pivot points, and then the Z position is going to be 0. Right front, this will basically put it at the right front, this is going to put it onto the left front, and this will put it onto the left rear. So these are basically going to be what we call the pivot points for the different wheels, to be able to get our 4 different wheels at those 4 particular points. So now let's go ahead and let's write the code to be able to put the wheels up there. And through the magic of television, here it is. A lot to have added here. The big thing here is that earlier in the build, I sat there and I left it commented out so I could show it to you. I created the wheel, set the position of it, and then applied the physics and posture. But now all that's been kind of split up. I now have a routine called add wheel, because we're now having to add 4 different wheels. So, you know, obviously, why repeat it 4 times? We've got one routine here to add the wheel. And all it's particularly wanting to do here is just create the sphere, do the position, and I'm going to set the visibility to true. Now, this is something a little bit new here. Eventually, this is going to be a mesh that will go on top of the physical mesh that has the picture of the wheel itself. So this particular mesh that we're creating here will control the collisions, while the other mesh will just make everything look pretty. So eventually we want to make sure that this cannot be seen, so we're going to be originally setting that to false. But for right now, in our particular case, we're going to set it to true. Okay, and here in the set physics, it's basically an exact copy of what we had before. I'm getting the restitution, the friction, and the wheel mass from our default wheels, which we had up here, which we had defined up here. And anybody who is a sleuth will realize, oh, in between when we talked about this up here, we didn't have restitution, but now we do. That's because I added it in just for a brief second there, because I realized I made a mistake, but it doesn't really matter. So we've got the restitution, the friction, and the wheel mass. We create our physics and posture on each particular wheel, and this is the exact same thing as we had before. And then I'm just returning a new mapping of each individual wheel. So the reason, and this is kind of a very strange line here, I'm redefining the variables that are coming from the wheel. And the reason I'm doing that is that eventually set physics is also going to work at the chassis, the joints, the box, and the meshes, and the original meshes themselves. So this is going to be a lot more here than we actually are needing at this particular point in time. But this allows me to be able not to have to rewrite this particular line of code, because basically I stole it from our FWJS.race. Anyway, doesn't really matter. So we've got the add wheel, which adds a single wheel here. We've got the set physics, which sets a physics on all the different wheels all at the same time. And so our build now basically says, hey, let's go through and loop through, and let's get a new map called wheels, where we add each of the individual wheels, and then let's set the physics and pass the wheels back, and then we'll set our particular, we'll set our array there to wheels. That's a new private variable. And also I got another private variable called name, which I've set right there. which is test car right here. And that just basically, again, is something we'll be using later on in the future. Each one of these cars is going to have a name. Of course it will. So that's basically, whoops, whoa, what happened there? So that's basically what we have. I think I did something strange. Nope, okay, we're cool. Okay, so that's basically all there really is to it. What we've added again is that we, to create the wheels, we've got our new defaults. We got our wheel parameters, and on the build here, we're now adding each individual wheel from an add wheel method, and we're setting the physics on all the wheels all at one time. So eventually, later on, we set the physics completely. So let's take a look at our 4 wheels, and let's save it, and let's flip over to our browser. And there we are. There's our 4 wheels. Doesn't that look great? So I know what you're saying. What the heck? What happened to our wheels on each side? Because we just spent all that time saying that, okay, this wheel's the left front, this wheel's the right front, and blah, 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 and so on and so forth. Why aren't they in the order we expect them to be? Well, the reason is that we have not applied any kind of positioning to them yet. And because of that, they're all being created at the same spot, but as soon as they add the physics to it, they're supposed to collide with each other, so they're separating themselves automatically. And that's what you'll end up with, this nice, pretty little row. Just them basically trying to get away from each other. So that's basically all there is to adding the 4 wheels. Those now represent our particular wheels. And that's going to pretty much end this video here. What we're going to concentrate on in our next video will be the really important stuff. That's what we call the joints. And the joints are going to allow us to be able to manually connect all 4 of these particular wheels into a single spot, so that then, by using that pivot that we had done before, the pivot is what has been, the pivot is this part right here. We'll be able to use the pivot then to be able to say, okay, this joint is located at this certain position from the center. This pivot is located from this joint is located from one position. This joint is located at another, and so on and so forth. So when we complete the next video, we will actually have something that will look a little bit more like a car. But that will be the next video. If you like this video, please click on the like button below, subscribe to this channel, or leave a comment. I'd love to hear from you. We're trying to get to 1 million subscribers by February of 2042. So, hey, time's running out. Thank you so very much for watching. This is the Virtuoid, aka Mike Smith. We'll see you later.